Okay, so now we are ready to actually talk about how you can create an abstraction for the birthday book. And you have already been exposed to this particular birthday book example in your Lab 0. So I just want to give you a quick review on what it really is. Okay, so now let's talk about some important points. So birthday book store a collection of entries where each entry is simply a pair of person's name and their birthday, right? Just see one example here. So you can think about, mathematically speaking, a birthday book is more like a you can think about relation, but in our for our purpose, I just want to show you variety. You can think about it's more like a specialized form of relation, which is a function, because every name should be mapped to at most one birthday. So a person cannot have multiple birthdays, right? So having relation is okay, but you have to put some extra restriction, which is what you have to do for lab number 2. But for now, let's make it a little bit simpler for you. So here you can think about the domain of the birthday book is simply the set of names. For example, you got Alan, Mark, and Tom, and Jim. So you got 4 entries over here basically. And the first entry will be Alan mapped to May 21st. The second entry will be Mark mapping to August 11th. And notice that it is okay for a function to say you have 2 domain values mapped to the same range. But the other way is not okay. You cannot say, for example, Alan was born on May 21st and also August 11th. It will not be a function anymore. So that's why we just want to use a function as a mathematical model for the birthday book. Okay, but you can also use a relation if you just put some extra constraint to say the image, the relational image on Alan, in that case, it should be a singleton set that's returned. For example, it should be a singleton set that's May 21st, right? I'm just trying to link to what you learned previously. So that's about the mathematical model for a birthday book, which should be just a function. That's something we'll adopt. Okay, let's go over some other things about the birthday book. So no 2 entries store the book are allowed to have the same name because it's just domain value. So it should be a set, right? It's also a search key from the implementation point of view. So it should not be any duplicates. Okay, so each birthday will be month and day. Okay, and then so now, when we first create the birthday book, it should be empty collection of entries. You can think about mathematically, it should be an empty function to begin with for the model. And what kind of operation can we perform? We can say you want to inquire about a member's birthday. Okay, so it's either detachable or detached, right? So we talk or attached. That's something we talked about before. Okay. Oh, sorry. This one just about number of entries. So also we can inquire about a person's birthday, right? You can also add a new entry by supplying the name and also the birthday, right? Assuming that the name does not exist just yet. So there should be some associated precondition. You can remove the entry. Okay, so given a particular person, let's say, for example, I want to remove the entry that's associated with Alan. For example, I might do that if I wish. Okay, and also we got find the birthday of a particular person. Yeah, that's what I just said. You can either make the return type detachable, so that it's a partial function, or you can make it just simply attached. In that case, it would be simply a total function. You want to see which one is actually more appropriate. Okay, so now you also can get a reminder list of names of people who share a given birthday. For example, if I give to you, let's say August 11th, in that case, the reminder list will just be Mark and Tom. Okay, so this is similar to the celebrates query in your birthday book application. Hopefully you can realize that. Okay, just one more slide before we get to the details. So you have to make some design decision over here. Decision should be made both at the implementation level and also at the design level. Let's talk about one by one before we get into the details. So what about design decision? So what classes should you have? How many classes? Well, as you learned from lab number 0, we know that we should really need at least the birthday and also the birthday book. But for this example here, I'll show you just one more class that you can also create. Okay, every time you want to do your project, think about what classes you need to really satisfy the modularity criteria, right, for the design. And also, should you have client-supplier relation versus inheritance? That's something also you want to think about. What should be the mathematical model here? Okay, as we just discussed, having a relation is okay, but it's more accurate to say it's a function. Okay, if you want to use relation instead as an extra exercise, you have to make sure the relational image always return a singleton set. That's something you have to pay attention to. Okay, in this case, we just say function. Okay, and also for the contracts, remember what we said in the previous week. We say that if you simply write your contracts according to the implementation attribute, for example, a hash table or maybe 2 arrays to store the names and birthdays separately, in that case, you will violate this single choice principle and also the information hiding principle. So what we want to do instead is to create a mathematical abstraction for all the possible implementation. Okay, so in that case, we can actually write a contract in terms of the model. So every time if you change the implementation from one to another, you only have to change just the model implementation itself. That's the only single place you have to touch. Okay, so what about implementation decision? So here you want to think about, we can say we can use 2 linear data structure, arrays and lists, to implement. In that case, we know that the running time will just be linear, right? Because every time you want to search, you want to go, in the worst case, you can go from the beginning of the name until the end of the names array over here. So that's why it's linear. Or if you want to improve the performance, you can say you can use some balance search tree, for example, AVL or splay tree even. So in that case, you can say log n, right? It's an improved performance in that case. But they should work equally well as far as the correctness is concerned. But of course, when you talk about implementation, you want to be as efficient as possible. And also you can use a hash table. And for hash table, if your hash function can really distribute the entries equally, in that case, you can also achieve a constant time for searching for entries, right? So it really depends on really what you need. So these are just some examples for the decision you have to make at the implementation level. However, at the design level, whenever we write contracts, we don't really write our contracts specific to either we choose this or this or this. In that case, we're exposing the details to the clients, which will violate information hiding principle. So what we want to do instead is we want to write every contract in terms of the model function. That's what we will do. Consequently, the most important step at the design level is we want to implement an abstraction function of type function in this case. So in the abstraction function, depending on what implementation we have chosen, if we have chosen 2 linear data structure, in that case, the model abstraction function must be implemented to really convert from 2 arrays or 2 linked lists up to a mathematical function. Or if you use a balanced binary search tree or AVL tree, in that case, you have to convert from the tree into the function and etc. And for the example for this particular lecture, I just want to show you just using a hash table. So that's kind of an easier case to convert from a hash table into a function. But you can definitely try. As a more challenging exercise, you can either try to do maybe from 2 arrays into a function, or from a balanced search tree using AVL tree or splay tree into the mathematical function. Right? You can try either one. But the contracts should not be changed whenever you move from one implementation to another. So that's, again, information hiding principle and single choice principle. You should really understand the distinction between the two and why they are satisfied when we use a mathematical function here, abstraction function. So let's now present the design of the birthday book using a design diagram, which we learned about in the previous part of the lecture about using the bond notation. And then the source code for the design and implementation using a hash table has been made available to you. So you can also go over them and play with the example and see in the debugger how the runtime relation is being created, runtime function has been created. Let me now present the design over here. Okay, that's the conceptual model you should really have about the birthday book being a function, which means every name should really be mapped to at most 1 birthday value. Okay, so now let's first of all take a look at the diagram over here. So let me start with the architecture before I talk about specification for the contracts. So we got 3 classes over here. So that's for modularity, right? You want to really decouple your functionality into different groups, and each group will be each group of features will be a class. Let's start with this particular class over here. That's the name class. In your lab number 0, we simply just got the class, we just used the string class to represent the name. But if you think about it, there's no constraint in lab number 0 to say, for example, if I simply got the name of the person, maybe 1, 2, Alan, for example. In that case, it will still be allowed if you simply say name is simply of type string. Because 12 Alan is definitely a valid string value. However, it should not be a legal name in the reality. So what we need to do instead, why don't we simply think about, since we know if all the possible string value you have is in this particular orange set, but only a proper subset should be allowed. In this case, maybe we should really make this proper subset a separate class with the appropriate classing variants. So that's something we'd like to do. So that's another design technique you should really know by yourself when you are programming in OO. So whenever you think that if a particular class is really way too weak, which might allow some illegal value or objects to be created at the runtime, in that case, you better create just one class yourself to really put the additional constraints so that you wouldn't get any illegal objects that violate the reality sense. So now in this case, what I did was I simply created one class just called name. It's like a specialized string values that's only for name. So over here we got item, for example, of type string, and now we got this particular classing variant to say only a name will be considered as valid if, for example, let's say the first character should be between A and Z. Of course, that's only mathematical notation. Just say the first character. But if you like, you can say maybe every character in the string should be a character, alphabets, basically. Of course, you can also add additional classing variant to further constrain about your name. Maybe, for example, it should be capitalized, or maybe you also allow everything to be lowercase, or maybe starting from the second character, you should all be lower cases, right? There are many constraints you can actually try to add for your own particular application. So for that one, I'm going to leave to you. But for now, you should notice that we are creating one particular class just for the specification of a proper name, in which case the first character should be capitalized. That's what we are saying here. Okay. So now we also got birthday class, and this one is not so bad. We got name, we got date, also we got month. For your tutorial, we got even better classing variant. If you recall, we also say what does it really mean to be a valid combination for month and day. But we're just omitting that details over here. But you know that this is just one module for your birthday, just one module. Okay. And then we also got this another module here for the birthday book. You can see birthday book has different purpose from birthday. So that's why they should be decoupled into two different modules. And for our purpose of writing contracts, we're using this abstraction function over here. You can see again, abstraction function simply means we want to promote the private secret implementation up to the level of mathematical objects. In this case, we're using a function where the domain is simply a name and the range is simply a birthday. So the conceptual model you should have is this particular diagram here, right? It's a function with the domain and also the range. Okay. And we're gonna how you actually promote your hash table into the model function. I can refer you to the source code. It's pretty straightforward to do, so I don't need to waste your time over here. And also we got some public queries over here. We got count, and also we got command for the putting a new entry. I'll talk about the contracts for the commands in just a moment. And also we got remind over here. The remind, given a birthday, we want to return an array of name. Okay. And also we got invariant over here. Simply say what does it really mean for your birthday book to be consistent. For example, the size of your book should be the same as the size of the abstract view as a function, right? That's just one example here. Okay, if you think you can think about more invariants, the more the better if they're appropriate. So now let's talk about client-supplier relation, which is also very important. Okay, so now remember what we said in the previous part of the lecture. Every time if you declare a variable, either an attribute, maybe parameter name for a routine, or it can be a return type. In these three cases, you're really introducing a client-supplier relation. And in your design diagram, you don't really necessarily have to show every client-supplier relation. Just be selective. Let's say, for this case, I'm only showing two. Okay, so the first one I'm showing this particular one. Because I know that I'm declaring model over here, let me just use a different color here. I'm using the model of type function. So a function, and then it's simply of name and also birthday, right? So now I want to emphasize I'm really using the supplier class birthday, right? I can also choose to emphasize on the name. I can also choose to emphasize on the function, right? I got different choices over here, but depending on what you really want to emphasize. Let's say I want to emphasize on the birthday. So what I would say is I'm going to put the birthday as a target supplier class. And you can see there's a client supplier arrow over here, right? As before. So now how should we fill it in? So that's my question here. Okay, you want to think about it by pausing the video before I reveal the solution to you. Okay, the solution should be something like this. Okay, so let's take a look what's really happening here. So now we say model really is of type function. And then the first generic parameter should be instantiated into name. And the second one is simply ... I know in the previous lecture I also say ... I would say I wouldn't be so strict on this. Either you can say ... 2 dots, or 3 dots. They mean the same thing. Okay, you can be a little bit relaxed on that particular constraint over here. And then, so when we say ... or ... it's really referring to the supplier class that we're pointing to. So this ... is as if we put birthday over here, but it would be redundant if we put that, because the arrow of the direction of the arrow already tells you the ... means the birthday. Okay, so this is just a review. We already addressed this in the previous part of the lecture about the sign diagram. Okay, just another one. What if I want to show, for example, you can see over here, you can see I put remind over here. So that means I'm referring to this particular query. So this is a client-supplier relation. Specifically, I want to say the target supplier is actually a name over here. Okay, it's a name over here. So now how can we do that, right? So now remind should be of is returning something, and then it's simply of type something of name, right? Name is the supplier I'm emphasizing. Okay, you can again pause the video before I reveal the answer. The answer should be something like this. Very similar to what we just said, right? Because the ... over here is as if we set name, the targets over here. But it will be redundant if we say that, because the direction of the arrow already suggests that. Okay, so you will be remind of type array ... over here. All right, again, if you say ... that's also fine. All right, so now what's left? It's about how you write the contracts, especially post condition, as examples that I want to illustrate. How do you write a post condition over here for the put command and also for the remind query over here using model, right? We want to really satisfy the information hiding principle, so we only show model in the post condition. At the same time, we also want to satisfy the single choice principle, so that once we write a contract for model, we don't have to fix them anymore. They'll remain stable. Later on, if I change my implementation, let's say from a hash table into a split tree, in that case, all I need to change will be just under the hood, the model implementation, which is hidden anyway, so it wouldn't affect the clients. Again, you should really review information hiding versus single choice principle. These are the very important two design principles you have to know. Okay, let's talk about put and remind, and to really help you on the thinking process, let's talk about put first of all. Okay, let me just give you some example over here for the put. Let's say currently I got Alan, Mark, Tom, and Jim, right? As we illustrated before. If I want to add a new entry where the entry name simply does not exist, let's say Hyung over here, and I want to put her birthday to be October 15th, let's say. In that case, it's basically just a new entry over here, so it would be quite straightforward. It would just be, for example, Hyung over here, and that will simply map to the corresponding value. In this case, October 15 is already there, so I don't need to create a new birthday object. So in that case, it will simply be mapped to over here. So that's scenario number one, where the new name over here does not exist. On the other hand, let's say maybe somehow there was a mistake when we first entered the entry. Let's say Tom, currently according to the database, he was born on August 11th. Let's say it's a wrong record. So now we want to modify it. We want to override it. In that case, I would say Tom, being an existing name over here, it should be modified to September 14th. So now in this case, what we are saying is Tom, rather than map to August 11th as indicated right now, what we want to do is so you can see September 14th is not there. I'll say September 14th over here, and now Tom should be mapped to that particular birthday, right? So these are the two scenarios. Either the person does not exist, or the person let me say it again. Either the person exists, number one, or the person does not exist. We want to handle both. Okay, so your contract should really say how this particular how these two scenarios can be corresponding to some model operation you perform. Okay, do you know which model operation this should correspond to? Okay, so for those of you who pay attention to the previous part of the lecture, you will realize, yeah, exactly, that's the relational or functional overriding we are thinking about, right? Basically, in the case of Tom, you can think about conceptually, right? Remember the two steps that we talked about. What you would do is, first of all, you're going to get rid of the pair that's to do with Tom. And then you add in a new pair with Tom and also the new September 14th. That's exactly the two steps that we talk about in the relational overriding. And as I said before, functional overriding is very similar to relational overriding. So that's basically just overriding operation. Okay, so this one is very easy. So let me just go back to the design diagram over here. That's how we should present this particular model operation, right? For put model operation. Let me just make it a little bit bigger. You can see. So now if I reveal it, you can see this is basically the answer. Okay, so we're basically just saying overridden by, and you should really look up to see what the declaration is. So this is basically a query. What it does is, you can think about what, again, we talked about previously. This is the call that's in the pre-states. This is the call that's in the post states. And we're saying that because in the post states, we're adding one more entry somehow. Either we override some existing entry or actually add one more entry, depends. So that will correspond to exactly how the overridden operation is going to work. And overridden by, in this case, simply just take one pair or one tuple. In that case, we'd say the name and also the birthday. That's why you see the ND over here. Okay, you can also look to see in the function class, there's also a way to really take a set of pairs to do the overriding. I'll leave that to you. Okay, but again, this is a query that's really important to realize. And I also put some comments over here. So for every relational operation, for many of them, actually not necessarily every, for many relational operation, we also give you the some infix operator. So now what you can do is, rather than just saying overridden by, you can also say model. Tell that over here, you can say old model dot, I'll just say, I'll write it shortly, deep twin. Okay, deep twin over here. So now rather than spelling out the operation over here, you can simply use its infix notation. You would say at. Okay, for those of you who learned about relational functional overriding, I think a very standard symbol is simply looks like this. That's why we made the infix symbol looks a little bit like that. Okay. And then you will simply say ND. So this is simply just another alternative way to write it, but it's not required. If you feel like you want to try the more symbolic way to use this particular symbol, feel free. Otherwise, you can also just simply just do a normal routine call. That's also equally acceptable. Okay, so that's about the put command, how we can write its model operation. So now we want to do for remind. Remind is actually a query, so you should not really modify the current birthday book. So let's see some easy ones, and then we'll talk about what kind of model operation you should really correspond to. We'll talk about it in just a moment. Okay, so now for nothing changed over here, because it's a query, so we want to make sure the model in the pre-states and the model in the post-state should remain the same. Okay, so this one should be quite easy. We can simply say like this, right? The model in the pre-states, take a deep copy, should be the same as the model after the operation, which should not change. So we just say model here, and they should be equivalent to each other using the is equal from the function class. And now we want to say another thing. These two over here are basically equivalent to the exercise that we just did about is all positive number, right? That example we did. Before I reveal the answer over here, let's talk about how we would do it based on our knowledge from the previous exercise. And then these two just present equals, semantically equal or logically equivalence alternative to you. So I can show you both. But of course you should know both because it depends on how I ask you in the quiz. So you should know both. Okay, let's take a look on the operation here. Let's say for the remind, okay, let me just give you two cases over here very quickly, and then we'll talk about how we can write a contracts. Okay. So case number one, let's say we want to remind August 11th. August 11th does exist over here. So that means we can now really try to remind both Mark and Tom. Okay, so what's really being returned is really these two names, not the pairs. Okay, so whatever I box into pink, so these are what I'm going to return is a remind result. On the other hand, let's do another one here. If I say I want to remind about November 29th, do we have November 29th in the range? We don't. We only got May, August, and October. So in that case, what it will return rather than void, right? Because remember the type over here. Remember the type for remind is simply just an array of name. So it's not detachable. So you don't really return void in this case. You should always return an attached array object. So conceptually, if somehow it should not return anything, in that case just empty, right? So this will return just empty array. Because the birthday you want to remind people about, it simply doesn't exist in the current birthday book. So it will just be empty array. Okay, so now let's go back to this more normal scenario and think about how we can do it. Okay, you may want to pause the video and think about what relational or functional operation this will correspond to, right? Think about this is like the model over here, right? Think about this is the model, and I only want to return whatever domain values that will actually map to the input month or input birthday over here. That's what I want to get, right? So now, what should be the corresponding operation over here? Okay, so hopefully you have thought about it. It seems like what we need is, first of all, in order to get this particular sub-relation over here, it would be a range restriction. Well, I want to restrict the pairs in the relation just by this particular range value over here. So let me say model, first of all, model dot range restricted by, okay, I want to say, let's say August 11, right? Of course, it will be ND in our particular general case, but I'll just say August 11. Okay, so once you say range restricted by over here, is actually going to return back to you a relation. Okay, let's first of all get it straight. So this particular expression over here is actually going to return back to you just a relation. However, your target is just to get just the names over here. So that would be the domain. Agree? Okay, so now the whole thing over here, that's why using a query can let you actually compose sophisticated expression one on another. Okay, let me just move this guy a little bit to the left over here. Okay, so now I want to call dot domain. So once you get range restricted by, and then you want to call just the domain. So I'm getting just the names over here. And conceptually, what you really want to say is that will be tilde equal to the result. Okay, conceptually. Okay. However, this wouldn't work in the programming context because if you think about it, the types are not really compatible, are they? You can think about this particular expression on the left hand side over here. Let's think about this one here. This is of type a set, because domain of a relation should be a set. On the other hand, this type over here, as you can recall over here, let me just go back there to remind you, you can see that type is simply an array. You cannot really compare a set directly to array, can you? No, you cannot. So that's an array. So now this is why I said what we said before is handy, right? In the exercise, you can think about now. You really want to say this set here is really the same as this particular set over here. You can think about it's a collection, so it's a set that you want to argue. So these, let's say this is S1, okay, and this is S2. S1 is actually one expression for a set. S2 is just another set. You want to say now S1 is equivalent to mathematically S2, and we learned about how you can do it. Let me write down what you have to assert, and then it should be an exercise for you how to write them down completely. Okay, I'll leave that to you. And the source code that you're given, actually try another alternative, which I'm going to show you on the previous page. But you should really try this one as well and write it in the source code, and then try to modify it and try to make sure everything still works and compile. To do this, we're going to say S1 subset of S2, and also S2 subset of S1. That's what you got to say, right? Okay, so let me just give you a little bit more hints. You want to say across every element in this particular set, they exist in the result. Symmetrically, across every element in the result, they also exist in this particular set over here. So you're going to do both ways. Okay, so that'll be my hints to you. Okay, you should really complete this extra exercise to make sure you really understand. Okay, having said this, let me go back there. Okay, so what you're going to see in the solution over here is like this. Okay, let me just give you a little bit more hints over here. The way we do it is to say, for example, S1 conceptually is a subset of S2. And also S2 is also a subset of S2 is a subset of S1. We know that it will be equivalent to S1 and S2. They're simply just the same set mathematically, right? So another way to do it is we can say, for example, we can say, why don't we simply do this? Let's say S1 the cardinality of S1. Okay, cardinality, which is S1.count. Cardinality of S1 is simply equal to the cardinality of S2. And maybe S1 is a subset of S2. So if I can assert this, it will be equivalent to when I assert this, logically speaking. Okay, hopefully mathematically you may want to think about it, but I'm just telling you, either you can write approach number 1, which is what's shown on the iPad slide we're going to show you, or you can try approach 2. And approach 2 will be corresponding to what we did in the exercise previously. Okay, again, for 1, you still have to prove just one subset relation, just prove one, either direction. And then you want to make sure these two sets are of same size. So that means subset plus this satisfy the subset relation, and also their size are the same. So that means they should be the same set, informally speaking. Okay, so now let's see exactly how 1 can be done over there. Okay, so you can see over here, the first one is about same count over here. Let me just reveal it. Okay, so you can see, first of all, the set I talk about model the range restricted by over here, the count, right? So you can see over here, model the range restricted by. Okay, so that's what we did before, and then the count should be the same as the result. Okay, result account is equal to that, right? So that's the first one. And then the second one, for example, we want to make sure every element in one of the sets is actually an element in the other set. Let's see what the solution is about. You can do either way, right? It's up to you. So the way we did it over here is, let me just reveal it. What we did was over here, we say across all the name in this particular set over here, right? So you can, basically we do, and then we want to say name is a member of the result. Okay, you can read this in more detail, but I'll just tell you what this does. What this does is, if I go back to this particular illustration over here, what it does is exactly over here. You want to say, number 1, they should be of the same counts, and number 2, every element in S1 is also an element of S2. So every element in S1, so you can think about this is S1. So every element in this particular, let me just circle a little bit better. Every element in this particular set is also an element of this particular set. That's exactly what the post condition is saying. Okay. Of course, you can try also to say cardinality of S1 is equal to cardinality of S2, and every element in the result is also an element of this. You can try just the other direction. That also work. So you really got 1.1 and also 1.2. You also got another 2 versions for approach number 1, right? So in total, you got 3 options for you to really write, but they are logically equivalent to each other. So I now have shown you all the 3. Okay, you should really choose which one to write. And of course, you should really understand the rationale behind each one of them. Okay, so now we are done at the design level here. Especially we talk about this particular model about the abstraction function. Let's now move on to a little bit, showing a little bit more details about the implementation. A little bit. Let me move on to this. So now, if you see this over here. So let me just tell you the only information the only new information I'm showing here. Number 1, you can see now we say the name over here. The name will be used since we're trying to use a hash table. So you can see feature exported to none. So this is like a private feature that the client wouldn't see. So it's simply implementation of type hash table of where the value is simply birthday and the search key will be name. So that's why the search key for hash table must be hashable. So that's why I'm saying this should be inheritance relation over here. So this is a new bits I'm showing to you. A little bit more showing the implementation strategy if necessary. Okay, so the name over here is hashable. Okay, and then of course you may have to define a hash function inside the name class. You can see the source code, and then you will see. Okay, and when we show the client-supplier relation, it's just the same as before. Okay, that one's actually not too bad. And then you're also showing some invariants over here. You say the size of the birthday book should be the size of the hash table. They should be matching, right? That's an extra invariant you had to say. And then the remind and also put. This is really important because we're using the math models to actually write the contracts. So the model contract will just be the same as before and the same as before. So we haven't modified them just yet. Actually, I shouldn't say just yet. We will never modify them because even if you change from maybe implementation of type hash table into split tree, in that case, you shouldn't really have to modify the post condition over here. All you got to modify will be over here, as we said in the previous lecture, will be about the implementation for the model query, the abstraction function. And the implementation over here will be up to you. That's also set in the source code. You can read the details. So now, what about the post condition for the model? Let me say one. Let me just show you, and I'll show you a common mistake. Let's just reveal these two quickly. Okay. So number one, we are saying that the same counts result.count over here, which is of type function. Function.count is equal to the hash table.count, right? So we are saying these two hash table at the implementation level versus hash table at the implementation level versus function at the mathematical level. Their sizes or cardinality should match, and also the content should be the same, right? So now similar idea again. You want to say for every name date pair in the result over here, which is a function, they should also exist in the implementation. So this is just mathematical notation here. You can see exactly in the source code how this can be done. Okay. So now let me talk about a very common mistake over here for you, with you. Okay. Let's say rather than result.count over here, sometimes students tend to write, what if I say model.count? What if I say that over here? Do you think this also will work or it wouldn't work? The answer is this wouldn't work, and even worse, you will get an infinite recursion. Because what's happening here is like this. When you try to evaluate model over here in the post condition over here, right? What it does is it's going to actually call itself. And then when it call itself, it's also going to evaluate the post condition, so it's going to call model again. So it will just go on and on and on. So it's going to be infinite recursion. So just be careful. When you write the post condition for the model conceptually, you shouldn't put model here. Also doesn't make sense. Okay? So this should be avoided. Okay? So you should also still use result. Having model over here in the post condition is going to get yourself into trouble. You should also only use result. When you use result, you're really referring to the function over here. Okay? So that's about this particular case study about the birthday book. Okay, so review them and then play with the source code, especially try to also try the different exercises I suggested over here. You can also try this approach over here and also this approach over here that we talk about. Okay, make sure you're getting comfortable with application like this and how you can create mathematical abstraction, and also review the two design principle, information hiding and single choice principle.